Okay, so problem number 2. The function is the integral from 4x to 2 of cosine t cubed dt. And I'm asking for f prime of x. Okay, the problem is, even if you tried to integrate this, it's not going to work. Because if you tried to do it, the antiderivative of cosine would be sine. But if you did sine of t cubed, derivative of sine is cosine, the angle stays the same, times the derivative of the inside, that would put a 2t squared, or a 3t squared in it, and we don't have it. So we can't even integrate this one using our strategies. But we don't have to, because I'm asking for the derivative. We know a derivative and an integral cancel each other using the fundamental theorem of calculus. But it has to be set up correctly. It has to go from a number to a variable. So if I need to flip this, we just put a negative in front, and we can go from our number to our variable. The derivative would cancel the integral and the dx. So we have our negative, we have our cosine. In that process, the t would get switched to the 4x. And then we have to think about the chain rule. What's the derivative of 4x? 4. And so that's our answer. So you would, because think about if you integrated and you plugged in the 2, that would be a constant. When you did the derivative of that 2, it would go to 0. So it's only the pieces that have a variable in them that would stay. Is that okay? Problem number 3. I want the total area. Okay, so when I say total area, we have to realize that in general, if you have things above the x-axis, it's positive, below the x-axis is negative. If I'm asking you to do this, I'm asking you to find the absolute value of it. I only want the positive part. So we first need to find out when this equals 0. So you could take out an x. And this would factor into x minus 5, x plus 3. Set those to 0 and we get 0, 5, and negative 3. So if you think about your graph, it touches the x-axis at 0, 5, negative 3. We know some things about x cubed. What's x cubed look like? A chair. And so it's got to start down here and end up here. So it would look like this. I'm wanting those pieces. But if I just integrate from negative 3 to 5, it will do this as a positive and subtract off that, and that's not what I want. So we need to go from negative 3 to 0, and then we'll go from 0 to 5. From negative 3 to 0, the curve is on top of the axis, so we can just go like normal. From 0 to 5, it's below. So if I integrate this, I will get a negative. So what do we have to do about that? All right, we're going to do the opposite of that to make it a positive. So then, if we integrate, we get 1/4 x to the 4th minus 2/3 x cubed minus 15/2 x squared. Doing that from negative 3 to 0. This one I'll go ahead and distribute. So negative 1/4 x cubed is 2/3 x cubed, 15/2 x squared from 0 to 5. Yeah. Did I say 4 or did I just put my 1/4 in front? Okay, so now if we plug in, if you put in a 0, we get 0. minus, if we put in a negative 3 over 4 would be 81 over 4, plus, that'd be negative 27 times negative 2/3, that'd be plus 18, minus 9 times 15. So 135 over 2, plus, put in a 5, so 5 to the 4th, we need 625 over 4. 5 cubed is 125 times 2, 250 over 3. 5 squared is 25 times 15. 375 over 2, minus, and then you put in your 0. Alright, so then if you add all this together, I don't want to spend too much of my time doing the calculations, but we then would go through and calculate this, and that gives us the 863 over 6. On the test, it would either be nicer numbers, or I might say set up, but you don't have to calculate all the way, or something like that, because I wouldn't probably expect you to do one quite this ugly in your head, but we should be able to get there. Any questions on that? Problem 4. All right, make sure you guys refresh your substitution. If you try to do these antiderivatives without substituting, you are going to lose a ton of points. When I look at this, why can I not just do this antiderivative? I have x's here and here, so this is currently a product. Can we undo a product rule? No. So we have to do substitution. So u is the inside. What's that going to be? Du, the derivative of that, would be 16x to the third dx. If I'm looking, I need the x to the third and the dx. I do not need the 16. So 1 over 16 du equals x cubed dx. Integral, this one didn't have limits, so we don't have to worry about that. We didn't replace the sign. 4x to the fourth became a u, and the x cubed dx became my 1/16 du. What is the antiderivative of sine? Negative. So it would be a negative 1 over 16 cosine of u. Since we don't have limits, we do the plus c. Final step, we don't have any numbers to plug in, so we need to put it back in terms of x. So u was 4x to the fourth. So negative 1 over 16 cosine of 4x to the fourth plus c. Is that one okay? So problem 5. Integral from 0 to pi over 2. Sine squared x means sine of x to the second cosine of x dx. So both of these have x's and they're multiplied. So this is a product, so we can't just undo it like normal. U would be what? U is your inside. So that would be your sine x. Du. Derivative of sine is cosine x, and with that we did a derivative, so it gets the dx. So cosine x dx is that piece. All right, currently these limits are x values. We have two options. We can either keep them, and then at the end we have to put it back in terms of x before we plug those in, or we can change them to make them u values. What do you want to do? Change them. So you are plugging those in to our formula. U is sine of x. So if I said the sine of pi over 2, what does that give me? It's 1. It's the square root of the top over 2. Radical 4 over 2 is 1. If you do 0, so square root of 0 over 2 is 0. So these are u values. That means I can plug those in for my u at the end. I never have to go back to x. Then my sign gets changed to a u, so it's u squared. The cosine x dx is my du. What is the antiderivative of u squared? 0 to 1. So you have 1/3 times 1 cubed minus 0 cubed. So 1/3 times 1 is 1/3. Number 6. Can I just do this antiderivative right now? No, because it has multiple x's multiplied together and I can't multiply them. So u is the inside. So my u would be x cubed plus 1. Du, what is the derivative of x cubed plus 1? We need the x squared dx, but not the 3. So that means 1/3 du will replace the x squared dx. Okay, so if we want to integrate, remember, these are x values. If we want to change them, we have to put those into our u formula. So u is x cubed plus 1. 2 to the 3rd plus 1 will give me a 9. If I put in a 0, 0 cubed plus 1 is 1. So we're going to integrate from 1 to 9. We have a square root of u, or I'll write that as u to the 1/2. And the x squared dx gets replaced with my 1/3 du. Right. Add 1 to the power. So that's 3/2. So you have to multiply by 2/3. So 2/3 times 1/3 is 2/9. From 1 to 9. 9 to the 3/2 minus 1 to the 3/2. 3/2, that means like the square root cubed. Square root of 9 is 3 to the 3rd is. Square root of 1 is 1, cubed is 1. So that would be a 26 times 2 gives me 52 over 9. Alright. Is that one okay? Let's look at problem 7. And roll from 1 to 2 of 2x cubed over x to the 4th minus 5 squared dx. Alright, is it possible to do this one without substitution? No, these things are divided. Since it's multiple terms on the bottom, I can't simplify that. So I'm going to do my substitution. U, what would you make your u value? X to the 4th minus 5. D, derivative of x to the 4th would be 4x cubed dx. We need 2x cubed dx. So what would I do to this? So divide by 2. So 1/2 du equals 2x cubed dx. If you didn't do it that way, you could have divided the 4 over, and then you would only be replacing the x cubed dx, so you'd end up with the 2 would stay times a 1/4, which is the same as 1/2. So you can get it a couple different ways. So if I want to change my limits, if x is 2, 2 to the 4th is 16 minus 5 is 11. 1 to the 4th is 1 minus 5 is negative 4. This would become 1 over u squared, or u to the negative 2. And this got replaced with a 1/2 d. Is everybody okay with how we got that part? So then, antiderivative, if we add 1 to the power, that's negative 1. Reciprocal in front would make it a negative 1/2. So negative 4 to 11. So negative 1/2. If you put in 11, 11 to the negative 1 is 1 over 11. Minus, put in a negative 4. So minus and negative would make plus 1 over 4. So that would be 15 over 44 times negative 1/2 is negative 15 over 88. Is that okay? Problem number 8. Integral x cubed minus 2 a square root of x, that's like x to the 1/2, over x dx. What do you notice about this one? Yeah, we only have one term on the bottom, so we could go ahead and just divide it. So if you did that, x cubed over x is just x squared. Minus 2, when you divide, you're subtracting exponents. 1/2 minus 1 would be negative 1/2. And then do we need substitution? No. So we have that tool, but we don't have to use it all the time. Antiderivative of x to the 1/2 would be 1/3 x cubed. Minus this one, if we add 1 to the power, would be a positive 1/2. So you need the reciprocal in front, so times 2. So that'll give us a 4. We don't have numbers to plug in, so we need the plus c. Are we okay on these substitution problems? Let's go to our areas and volumes. Alright, sketch the region enclosed by the curve 6 minus x squared. What does x squared look like? Parabola. What would a negative x squared be? Flip it, and the plus 6 takes it up 6. So we have this upside down parabola that's been shifted up. Okay, and then the other one, x squared minus 12. So x squared is a parabola. The minus would move it down 12. So you won't have a graphing calculator, but this picture I would expect you to be able to draw. You know what x squared looks like. We know enough transformations. That one's not too complex. I'm not looking for a real crazy accurate graph here. We know that when we set this up for area, we have to do top minus bottom. Okay? So we need to know where these things meet. Now my graph is not accurate at all, so I don't really know. But we are doing this in terms of x. Okay? Which curve is on the top? So we'll do the top curve minus which one was on the bottom. So if those are x's, that means this is a dx, so my limits have to be x values. So I need the x values when these things meet. So you set your equations equal to one another. So if we add over our 12, add over the x squared, so x squared equals 9, so x would be plus or minus 3. So we are going to integrate from negative 3 to positive 3. Alright, so if I give you one like this on your test, will you guys be able to set it up, draw me a picture, and find those points. Now, areas, we aren't doing any of the extra like pi r squared stuff. We are just integrating top minus bottom. So you could straight integrate from here. Probably would not be a bad idea just to simplify what we could. So then 6 plus 12 is 18. Negative x squared is negative 2x squared. Antiderivative of 18 would be 18x minus 2/3 x cubed. So if we put in a 3, 18 times 3, 3 to the third is 27, divided by 3 would be 9, times 2 is 18. You put in a negative 3. Negative 3 times 18 is negative 54. Negative 3 to the third is a negative 27, so 2 negatives make a positive. That'll be an 18. Alright, so we get 54 minus 18 is 36 minus negative 36, which gives us 72. So, expect some problems pretty similar to these on your test. Any questions there? Problem number 12. So another area, but my curves are x equals y cubed plus 1 and x equals y plus 1. Would this one be easier to keep it in terms of x or y? Y, because I don't really want to solve this and get it to be y equals. I would put cube root, so it would be a little bit uglier and doable, but maybe not nice. If we think about our curves, this one is just a line, isn't it? If you're thinking about x like y equals x minus 1, so it's a line with a y-intercept of negative 1, slope is 1. Y cubed plus 1. If you're not sure what that looks like, you could certainly solve for your y. So y would be the cube root of x minus 1. What does a cube root look like? A sideways chair. And that minus 1 would move it to the right one. So we're getting something like this. So we need to find both of those. All right. I still think it's probably better to keep this one in terms of y. If we want to do x, we'd have to find the x values where they meet. If we want to do y, we find the y values where they meet. So I would just set these originals equal to one another. So if we find where y cubed plus 1 equals y plus 1. If you bring everything over, the 1's cancel, take out a y, and you get y plus 1. So y equals 0, negative 1, and positive 1. So these meet 3 times, which we saw in our picture. So we'll have to go from negative 1 to 0, and from 0 to 1. Those are y values. So when you're dealing with y, you do right curve minus left curve. How will you know if you do it wrong? It'll be negative. These areas should be positive. If you're getting a negative, you know you flipped them and you need to do the absolute value at the end. So if I'm looking between negative 1 and 0, which one is on the right? It was y cubed plus 1. minus the curve on the left was y plus 1. This would be a dy. From 0 to 1, the curve on the right is y plus 1 minus the curve on the left is the y cubed plus 1. You could integrate, I'll go ahead and just combine like terms, so we get a y cubed minus y, the plus 1 and minus 1 drop. And this would be y minus y cubed plus 1 and minus 1 drop. So antiderivative of y cubed would be 1/4 y to the 4th. Antiderivative of y would be 1/2 y squared. We made 1 to 0. Same thing over here, they're just flipped. So now if you plug in a 0, that just gives us 0. Minus, we put in -1, we get 1/4 minus 1/2. Over here, if you put in a 1, you get 1/2 minus 1/4. Minus, put in 0, we get 0. 1/4 minus 1/2 is a -1/4. So minus a negative makes a positive. And this is the step right here. That's when I would know if I'd done it wrong. If you got a negative, you know you flipped them. Right here, this would be a 1/4, and 1/4 plus 1/4 is 1/2. All right. Yes.
Okay, when do we do the negative in front? Like, we plug in a number and see if it's. Is that something else?
Yeah. We were doing that when we were just doing like between the x-axis and that value, because the x-axis is like a height of y equals 0, so it's like 0 minus that.
You're welcome.
Does that make sense? Yeah. So when you're doing the x-axis, it's the same thing, top minus bottom. It's just that other curve is 0. So it's like either the top curve minus 0 or 0 minus the curve underneath, which makes it a negative.
All right, thank you.
You're welcome. Other questions? On 13. Find the area of the region bounded by the graphs of y equals 3x plus 1. So that's like a line, shifted up 1, slope of 3. Y equals 7. What's that? Horizontal line of 7. And the y-axis. So we are talking about this little region. Okay. So if we set this up, the equation is already y equals, so let's see if we can just keep the x and go with it. So if you're dealing with x's, you do top curve minus bottom curve. Do we have a clear top and bottom? Yes. What's my top curve? Minus, what's the bottom curve? Okay, we need our intersection points. So, we need our left and right hand points. This point is where our line, 3x plus 1, was equal to 0. This is where the 3x plus 1, oh, hold on. We don't want to say equal to 0, though. That one, okay. It was if you set it equal to 0, you're finding the y value. We don't need to find the y value there. We're looking at, so we could just say this one is starting at 0, right? Our x is 0 right there. This one, if we're trying to find this x point, that's when 3x plus 1 is equal to the line y equals 7. So 3x plus or 3x equals 6, so x is 2. So because these are x values, so those are the 0 and the 2. Everybody clear on that part? And again, I'm using x values because we kept x in our equation. If you had kept y in your equation, you would have to find your y values. So now we could simplify. So 7 minus 1 would be 6 minus 3x. Antiderivative of 6 is 6x. Antiderivative of 3x is 3 halves x squared. So if we put in 2, we get 12 minus 6. Put in 0, we get 0. So we get 6 for our final answer. All right. 14. All right. When I start talking about volume, that's when we have to integrate the area. So that's when we start doing the pi r squareds. So if we're finding area, it's just top minus bottom or right minus left with our curves. But volume is the pi r squared. We have the curve x equals 3 square root of y. Okay, if you were trying to figure out what that looked like, you could solve 2 squared, that's a 1/9 x squared. We know x squared is a parabola, so we're talking about a parabola. So something like this. X equals 0. So if I'm bounding by x equals 0, that's a vertical line at 0, that's just the y-axis. So I'm starting it here. Y equals 9, so that's my top. We're stopping at 9. And then if I rotate that around the y-axis, so I've talked to you about rotating, it's kind of like reflecting, but then thinking this is a three-dimensional object now. So, the trick I told you, if you're rotating around a horizontal line, then you keep it in terms of x. If you're rotating around a vertical line, keep it in terms of y. So, vertical line, so we're going to do in terms of y here. What is our lowest y value? What is our highest y value? Okay, we're integrating the area. So pi times the radius. If you take a cross section, the radius is going to go from here out to the curve. So my radius is just my equation squared dy. So if you square that, it gives me a 9 pi y dy. Antiderivative of y is y squared, so that would be a 9 pi over 2. From 0 to 9. 9 squared is 81, 0 squared is 0. So 81 times 9 gets us 729 pi over 2. Are we good on that? 15. I want to move fast. Curve. Y equals negative 2x minus 8. So that's a line. Y-intercept of 8. Negative slope. So it's decreasing. X equals 1 is a vertical line at 1. So that means I'm chopping off that part. X equals 3 is a vertical line at 3. So I'm taking away this. We're just taking that little section of our line. And we're rotating that about the x-axis. So to rotate it, think of reflecting. So we get something like this. Volume, pi r squared. Since we're rotating around a horizontal line, will we do it in terms of x or y? X. Okay, so left to right, what is our starting point? And our ending point? Okay, we integrate, the radius is just that function, which was 8 minus 2x. So if we FOIL that out, antiderivative, then that would be 64x minus 16x squared plus 4/3 x cubed from 1 to 3. And then for the sake of time, I'm not going to work that out, but you plug in your 3, you plug in your 1, subtract them, and that gives us 104 pi over 3. Are we okay on those? All right, problem 16. Sketch the solid obtained by rotating the region bounded by the curves. Y equals x squared, so that's a parabola. Y equals the square root of x, so that looks like this. So I am taking that region right there between them and rotating that around the x-axis. So if I rotate that, this is more like a bowl. Okay, that's solid on the outside, but it's hollow in the middle. So we'll integrate. We need right to left. So we need to find out where these curves are equal, because I didn't give you starting and ending points. I would probably square each side first, so you get x to the 4th equals x. So x to the 4th minus x equals 0. Take out an x. If you set those equal to 0, you get 0 and 1. Okay, when it was hollow, we had to do that. Pi times the outside one squared minus pi times the inside one squared. Okay, horizontal line, so we're doing x's, so I'll dx. You could, would you guys be okay if I just pulled my pi out in front rather than putting it on both of those? Does that bother anybody? Just cleans it up a little bit in here. Okay, so my outside radius, if I'm starting here and going to the outside, which one's on the outside? And the inside is my x squared. So pi times the integral from 0 to 1 of x minus x to the 4th dx. Antiderivative of x, 1/2 x squared. Antiderivative of x to the 4th, 1/5 x to the 5th. Again, 1 minus, plug in 0, 0. So 3 pi